Okay, here are the notes for section 2.4 on matrix operations. All a matrix is it's just used to represent data. It's like an array of numbers, but it will have these square brackets around it. Alright, so with numbers on the inside, so that's a matrix. Let's look at this first example, and it says Pierre's math quiz grades are 24 on quiz 1, 23 on quiz 2, and 16 he got on quiz 3. Then Gwen's quiz grades are 19 for quiz 1, 25 for quiz 2, and 21 on quiz 3. Represent this data using a matrix. Now, there's two different ways you can do this depending upon which way you, like what data you put in the rows and what data you put in the columns. So let's just do it sort of across this way, and let's do Pierre. He'll be the first row, and then Gwen will be the second row. Alright, then the first column will be quiz 1, second column will be quiz 2, and the third column will be quiz 3, like that. Right? Just a matrix of numbers. So Pierre, let's listen. Pierre for quiz 1 was 24. For quiz 2, he got 23, and for quiz 3, he got 16. Do the same thing for Gwen. Gwen, she got 19 on quiz 1, 25, and a 21. Right? So there's a matrix right there where your rows are the students and then the columns are the quizzes. If we flip that around, you could do it a different way. Let's put quiz 1 for row 1, quiz 2, and quiz 3, so those are going to be the rows, and then Pierre will be first, and then Gwen, the columns. We're going to represent this exact same data with a different matrix. So let's fill these in. Pierre now is going down this way, so he got 24 for quiz 1, 23, and 16 going down that way. And then Gwen, she got a 19, quiz 1, 25, quiz 2, and 21. So you can see that these are two separate matrices. They're not equal. We'll get into equal matrices a little bit later, but represents the same data, two different matrices. So either way you want to write it is okay. Alright, so the size of the matrix is going to be given by two numbers with this little x in the middle. It's not multiplication. It's the number of rows by the number of columns, like a 2 by 2, for example. Oops, I think I dropped my pen. Alright, there's an example of 2 by 2, something like that. Alright, so now let's look at this next example. It says determine the size of each matrix. Here is part A. Remember that you always put the number of rows first and then columns. Alright, so if you can count, there's 1, 2, 3 rows here. Yeah, here's part A. The number of rows is 3 by the number of columns is 2. So this is a 3 by 2. Let's look at part B again. The number of rows, you count how many rows there are this way. Here, this is 3 rows, and I have 1, 2, 3 columns, so that's a 3 by 3. That's how you say it, 3 by 3. Oh, your part C, 1, 2 rows by 1, 2, 3, 4 columns, 2 by 4. Notice that a 2 by 4 is completely different than 4 by 2. The first number is always the number of rows there are. The second one is the number of columns. Columns go up and down, the rows go sideways. Alright, so be careful on part D. How many rows are there? 1, 2, 3, 4 rows and 1 column. That's very tricky because some students want to call this a 1 by 4. That's a 4 by 1. Remember to count the rows first. Alright, so that's not bad. That's determining the size of a matrix. Make sure you can do that in web assign. We'll do very similar ones. Now, let's talk about equal matrices. right? In order for two matrices to be equal, they must have the same size, and the corresponding entries have to be equal. Let's see, are these matrices equal? First of all, this is a 2 by 2 and that's a 2 by 2. So their sizes match. Let's check the corresponding entries. Alright, those two entries correspond. I can already see this is not equal, but I'm going to color code it. It's easier to see that way. Alright, all those are corresponding entries, and they have to be exactly the same. And you see the yellow ones, those are already off, so this is a big no. Alright, even though they're the same size, they're both 2 by 2s, but the corresponding entries are not equal. Okay, let's look at part B. Notice in part B, let's look at the size of these. For this first one is a 3 by 1, and this is a 3 by 1, and the second one is a 1 by 3. So right off the bat, you can stop and say, no, those aren't equal. The sizes aren't equal. Now let's look at part C. I'm going to color code part C, because we have to check these corresponding entries to see if they're equal. And they might look a little different, but these are actually going to come out to be equal. Let's check it out. Alright, let's take the yellow highlighted part ones first. That's row 1, column 1. 6 minus 1 is equal to 5, so that one checks. How about the blue ones? 1/5 is the same as 0.2 if you divide it out. That's the same. Let's look at this green ones. Negative 2/5 is the same as negative 0.4. You can plug it in your calculator if you don't believe me. It's true, and then 2 squared is equal to 4. This is a yes. Those two are equal. Maybe they didn't look equal just glancing at it, but they are. So what you have to do is make sure you check the size. That's a 2 by 2 and that's a 2 by 2. Then you can check those corresponding entries. Alright, so watch out for little tricky stuff in WebAssign when you're doing your homework. That brings us down to matrix addition. In order to add matrices, first of all, they got to be the same size, because if they're different size, you cannot add them. And then, in order to add them, the corresponding entries, they have to be equal. Alright, so you check the sizes first. Alright, for part A, both of these are 2 by 2s. You can eyeball that. So what you do is add those corresponding entries. I'll write this one time, but then I won't do any more. 3 plus 0, that's that one plus that one. And then for this position, 0 plus 1. In the second row, first column, negative 1 plus a negative 2. And then the last ones, I'll have a negative 4 plus 10. Alright, totally don't have to write that out. Just go ahead and add them. So it's going to be 3 and a 1, a negative 3 and a 6, just like that. So that's your answer. Do not have to show me that middle step at all. Don't worry about that. Just go ahead and make sure the sizes are the same and that you're adding those corresponding entries. Alright, let's try part B. Ooh, notice the size on this one. Notice this is a 3 by 1 and this is a 2 by 1. Alright, that's not possible. You cannot add those together. It's a 2 by 1. Alright, let's go down to part C. Both of those are 3 by 3s. So I'm not going to write that step out where I'm adding them together, writing that out. Just go ahead and add them. Alright, let's take the 1 plus the 6. I'll get a 7. Let's take 0 plus negative 8. Going right across that first row. 1 plus 13. It's going to give me a 14. Alright, let's do row 2. 3 plus 21. 24 there. 2 plus 0 is 2 in the middle. And a negative 4 and a negative 5 is a negative 9. Yeah, 2 plus 0 is 2. Alright, down here, 5 plus negative 10 is negative 5, 8. And 6 is 14. And the negative 1 and negative 2 should be a negative 3 there. All of that if you add two 3 by 3s together, your answer will be a 3 by 3. It's got to be the same size. Alright. Then the last thing, this is kind of a quick little section, I guess. It's pretty straightforward. Here's scalar multiplication. What we mean by a scalar is just a number that will be out in front of a matrix. What you do is multiply every element inside that matrix by that scalar, by that number that's out front. Right? So it's not rocket science or anything, you just make sure you can multiply. So this is 3 times this, that's a 1 by 3. Right? So 3 times a negative 1 is negative 3. 3 times 3 is 9. 3 times 0 is 0. Just like that. Right? Don't make it any harder than it is. Just go ahead and multiply everything in there by the number out front. Now there's a negative 1 out in front of here. Let's go ahead and just change all those signs. Alright, 0 is going to stay 0. So it's a positive 1, positive 3, negative 4, positive 5, negative 7. Just watch your signs. Negative 8, negative 1, and 0. Just like that. Okay, let's write this one kind of down here. Yikes, I might have to put D over there. Alright, here's part C. What I'm going to do, I have to take a negative 1/2, so I have to change signs, and I have to divide them all by 2. Multiply by half is the same as multiplying, or dividing by 2, multiplying by 1/2, same thing. Right, it's negative. Negative 1/2 times negative 8, positive 4. Again, I'll write that in a minute. Negative 1/2 times 10 in the middle will be a negative 5. Right, my pen stopped working. It's Word actually that's not responding. Alright, and then the negative 1/2 times a negative 16 should be a positive 8 down here. So you should have just one column of numbers. If I can get this to work again, show you what that column should be. Positive 4, negative 5, positive 8. Just like that. Yeah, it blanked out there for a while, but eventually came back. Okay, I hope it stays here. And to finish this very last one, let's take 5 times this whole matrix. Alright. One second. Alright, I think the battery was disconnected in my little pen, my stylus here. Alright, let's take 5 times this last one. So 5 times 3 is going to be 15. 5 times negative 10, negative 50. And 5 times 8 should be 40. That's the first row. Good. Let's do that very last row. 5 times negative 5, negative 25. And 5 times negative 1 is negative 5. 5 times 0, 0. There you go. Alright, much better. So that should get you through the homework, and that's all of section 2.4.